Hello and welcome to the ProLongevity podcast. I'm Graham Phillips and welcome to the second episode with world-leading Professor Robert Lustig. In our second episode, we'll be discussing the cell biology behind metabolic disease and the toxic nature of sugar and ultra-processed foods. So sit back, listen and enjoy, and do let us know what you thought in the comments below. So that is, in fact, you brought me on to my next question, which is what I think you call it Cell Biology 101, which is chapter 7. And you go on to describe these eight processes. And it's with great clarity. So would you be kind enough to sort of take us through that?
Absolutely. So these 8, and I call them in the book the hateful or the grateful 8, with apologies to Quentin Tarantino.
Yeah.
All right. So these are subcellular processes that always go on. Okay, you can't stop them, but it depends on how fast they're running, and there are things you can do to modulate those. All right, and here they are. Number 1, glycation. So glycation is what causes hemoglobin A1C to form. So diabetics know all about hemoglobin A1C, and obviously the higher the blood glucose, the higher the hemoglobin A1C. That's true.
Yeah.
Point is that glycation process is underlying the changes in diabetes that lead to chronic disease. What it's doing is it's causing the proteins where this glucose is binding, non-enzymatic glycation, so a binding of glucose to a protein. It's causing it to become less flexible. It's causing it to potentially not be able to bind other hormones, receptors, or activate kinases like they should. So it basically wears it out and becomes sort of stiff and inflexible. And that has its own metabolic detriment. And every time that reaction occurs, number 2 occurs, called oxidative stress. Now, so when that reaction occurs, that Browning reaction, that's why you get cataracts and wrinkles, is glycation. Every time that reaction occurs, you release a reactive oxygen species, an oxygen radical, like a little hydrogen peroxide.
Yeah.
Now, hydrogen peroxide is good when you're trying to kill the bacteria on a wound on the outside of your body. It's really not good when you're generating it inside your cell, because it'll kill your cell. So you have to quench the toxicity of the oxygen species, okay? And antioxidants do that. And the antioxidants are located in a part of the cell called the peroxisome. And if you have enough antioxidants and your peroxisomes are working well, then you can do that. You can quench those reactive oxygen species. But what if you're eating processed food and you're not getting enough antioxidants? Then those reactive oxygen species are going to run rampant, and the peroxisome is not going to be able to do it. And what's going to happen is you're going to end up with something known as the unfolded protein response, or endoplasmic reticulum stress. And it has been shown that this phenomenon is what leads to insulin resistance in the liver and insulin deficiency in the pancreas. Basically, that process is what leads to diabetes.
Yeah. So
you got to clear out the oxygen radicals. All right. Number 3, mitochondrial dysfunction. So mitochondria are where cells burn energy, but mitochondria can burn it well or it can burn it poorly. And when it burns it well, you get lots of ATP, adenosine triphosphate, which are the chemical, it's chemical energy that your cell uses to power itself.
Yeah.
And if they're burning poorly, then you're not going to get as much, and you're going to get leaky mitochondria that can make more reactive oxygen species. So you have to have, shall we say, fresh and able and agile and strong mitochondria. And there are a lot of things you can do to poison your mitochondria. And if your mitochondria are not working well, you're going to end up with chronic metabolic disease as well. Fatty acids, the type of fatty acids you take in, contribute to whether your mitochondria will work well or not. Yep. And it turns out there is one particular toxin that poisons mitochondria directly, and it's called sugar.
And fructose in particular?
And fructose in particular. Glucose, the the other molecule in sugar actually makes mitochondria work better. It activates an enzyme in the mitochondria called HADH, hydroxyacyl-CoA dehydrogenase, which actually increases mitochondrial ATP output. But fructose inhibits three separate enzymes necessary for mitochondria to work normally. AMP kinase, which is sort of like the power switch for the mitochondria. ACAD-L, acyl-CoA dehydrogenase long chain, which is the enzyme that starts breaking up the fatty acids into its component 2 carbon fragments to make ketones. And finally, CPT1, carnitine palmitoyl transferase 1, which is the regenerator of the shuttle that the mitochondria use to get fatty acids into the mitochondria for burning in the first place. So fructose, and therefore sugar, ends up being a mitochondrial toxin. Yeah. We always say that sugar is energy. No, it's not. It's energy if you burn it in a bomb calorimeter. It actually inhibits energy generation if you consume it. So this is a major sort of revelation for people, is that sugar is actually a toxin. Okay, toxin to your mitochondria. Number 4, insulin resistance. Now, everyone's heard of insulin resistance nowadays, but no one knows really what it means. Turns out it's true that when you are insulin resistant, your body doesn't work well. That's true. But different organs in your body can have different degrees of insulin resistance at any given time. And everyone thinks that obesity is the cause of insulin resistance. That turns out to be on its head. It's really insulin resistance that's the cause of obesity.
Absolutely.
And understanding that subcutaneous or big butt fat actually contributes very little to insulin resistance, but liver fat and visceral fat are the primary drivers of insulin resistance, make people realize, oh, okay, it's not the fat on my behind that matters, it's the fat in my belly. It's not the fat I can see, it's not the fat on the scale that matters, it's the fat I can't see that matters. Right? And then the question is, where'd that come from?
Exactly. And I think the point is that it's not the amount of fat, it's where the fat is.
That's right.
And actually a tiny amount of fat in the liver and in the pancreas and wrapped around the viscera that you can't see, but doesn't weigh very much, is the clue here.
That's right. Exactly right. So insulin resistance, but you have to know why. And not everybody has the same reason for their insulin resistance. So if you're really going to attack the problem, you have to understand where the problem's coming from. And so that's why you need personalized nutrition.
Yeah.
Number 5, membrane instability. So, imagine all of your cell membranes are like balloons. So imagine you blow up a balloon, all right, to its, before, right up to its breaking point, but it doesn't break, okay? So you've got a blown up balloon. You try to use your finger to pop the balloon. Can't do it. Just comes right back, right? Now, if you use a pin, it'll pop.
Yeah.
Right? But your finger can't do it. Now, let that blown up balloon slowly deflate over, say, 2 to 3 weeks until it's finally like deflated, right? Because the air will escape, through the membrane. Now take that same balloon that had been blown up and blow it up again. Now use your finger. Now you'll pop it.
Yeah.
Okay. You have changed the membrane fluidity because of the stress on the membrane. Well, that happens to all your cells, and especially your neurons. And so there are things you can do to try to support that membrane fluidity to make those neurons and cells in your body in general much healthier and be able to withstand that distensibility. And they're called omega-3 fatty acids.
Yeah.
That's what omega-3 fatty acids do. They help stabilize membranes and they help promote neurotransmission in a good way in the brain. Okay. Number 6, inflammation. Now, we've always known inflammation is bad for you. All right. I mean, it's good for you when you're trying to fight off an infection, but it's bad for you when you're not. Okay. And it's bad for you when you overdo your inflammation, like COVID-19, the cytokine response. That's what ultimately kills you. All right. So regulating your inflammatory response is absolutely essential. But if your inflammatory response is going on all the time, then that's really bad. All right. So how come everyone's now inflamed? And the answer is because it's coming from your gut.
Yeah.
Your gut is inflamed. Well, why is your gut inflamed? Well, because you're not feeding the bacteria in your gut. You're not feeding the microbiome. And so when you don't feed your bacteria feed on you. They actually strip the mucin layer right off your intestinal epithelial cells for food. And that denudes the intestinal epithelium and allows for stuff in the intestine that shouldn't be getting into your bloodstream to be able to get there. And that's called leaky gut. And so this phenomenon of leaky gut lets the cytokines, the polysaccharides, whole bacteria for that matter, in, and then that goes to your liver and causes liver inflammation, and that causes liver insulin resistance too. All right. Number 7, methylation. So your DNA can be methylated in certain places. And when it does, that means it's going to change the transcription of whatever that gene is, and likely, in most cases, decrease the amount of whatever it is that's being made. And so you're going to end up having cell dysfunction because you methylated a place you shouldn't have. Well, that's what folate and B12 are for, is to sort of limit that degree of methylation. All right. And, B12 is in relatively short supply unless you take B12 shots.
Yeah.
And finally, number 8, my favorite, autophagy. So autophagy is self-eating, autophagy. Okay. What it is it's clearing the garbage. Right. So your cell makes garbage, just like you do. Right. So let's take your house. Right. And, the garbage men come and pick up, your garbage every week. But what if they go on strike? Well, the first week, not much. Second week, it's going to start to smell. Third week, you might get some, unwelcome visitors in the form of
a few rats. Yeah.
And by the 4th week, the rats start coming. By the 5th week, your drains are going to be starting to clog. Okay. By the 6th week, you're gonna have to move out of your friggin' house.
Yeah.
Right? It's a buildup. All right. But the bottom line is you got to take the garbage out. All right. They got to come collect the garbage. Well, autophagy is garbage night for the cell. All right. Every cell in your body makes garbage. Protein aggregates, lipid peroxidation products, defective mitochondria. They have to be cleared out. Otherwise, you're building on landfill. All right.
Yeah.
So, all right, you want your cells to be as streamlined as possible. They got to clear the garbage. And that's a process called autophagy. And it turns out there are certain things that can inhibit autophagy. And all the things that inhibit autophagy also contribute to chronic metabolic disease. So, and by the way, that's why you sleep. That's garbage night for the brain.
Absolutely. Yep.
So that's what's happening while you're sleeping, is all the junk is actually being removed because the pressure in your head has gone down while you sleep. And that allows for these openings between the brain and the coverings of the brain, the meninges, to open up, and they're called glymphatics, and they allow for cerebrospinal fluid to wash over them and basically rinse your brain every day to get the junk out.
Yeah. So
these are the 8 pathologies that are going on in your cells. You can't stop them. The only way to stop them is to be dead. But those 8 pathologies are what ultimately determine how long you're going to live and how well. And it turns out, when you actually look at the molecular mechanisms of each of these 8, and I lay it out in the book, not one of them is druggable.
Yeah.
They're all foodable.
Which is why I call myself the pharmacist that gave up drugs.
Right. Well,
because that's the conclusion I reached. Yeah.
So it works at every level, but except, of course, for the food industry.
Yep.
And so, teaching people what the real story is part of my job. So I'm going to pose a question to you, Graham. And I've been posing this question around a little bit now. So I'm going to see how how it lands on you.
Yep.
Is ultra processed food food?
Well, I've read the book and I've seen the video, so hand up, I know the answer, and I completely agree with you. So you've kind of preempted another question, but let me answer it. It's calories. It sure as hell is calories. As you know, if you put it in a bomb calorimeter and burn it, you'll get energy out.
Yep, that's true.
And this is where I think we've got
food.
It doesn't make it food.
So,
and I think this is what is such fundamental importance. And this is where the whole myth around calories. I was going to ask you, why isn't a calorie, but we've kind of come to that by, a different route. Yeah. So stuff that contains energy, but which is also a poison, which is what I think ultra processed food is.
That's right.
By your definition and by my understanding, it's not food. It's empty calories. It's devoid of nutrition. It won't ever make you satiated because of the lack of micronutrients. So if you think that food just equals calories, by that definition, it's food, but by any other definition, it's not.
Well, so in fact, Graham, we have to define the word food.
Yeah.
So let's do that. So if you go to Webster's and you look up food, it says substrate used for either growth or burning of the organism. I'm okay with that definition. Yep. That's growth or burning. Okay. So let's take burning first. I just showed you how fructose, that sweet molecule in sugar, inhibits burning. It inhibits mitochondrial function by inhibiting 3 separate enzymes. So even though it's calories, if you stick it in a bomb calorimeter, you get 4 calories per gram. It's actually inhibiting your mitochondrial ATP generation. Therefore, it is inhibiting burning, right? And Kevin Hall at NIH showed that if you give people unprocessed food versus ultra-processed food, exact same number of calories, exact same composition at every level, but one's ultra-processed, one's unprocessed. Turns out the ultra-processed food will make you gain weight, whereas the unprocessed food will make you lose weight.
Yeah.
Okay. So clearly something's happening in burning.
And it's clearly not the calories.
And it's not the calories.
Yeah.
All right. So that's so in fact, the burning part is not met. The criteria are not met.
Yeah.
Now let's take growth. So my colleague, Dr. Efrat Monsenigo-Ornan, who is the head of nutrition at Hebrew University, Jerusalem, just published a paper in Bone Research showing that ultra-processed food actually inhibits growth. It inhibits skeletal growth. It inhibits cortical bone formation very clearly and ultimately leads to stunting of growth. In fact, a paper just came out showing that the Dutch, who are the tallest people in the world, this generation of Dutch are shorter than the previous generation. How is that?
Yep.
All right. Where'd that come from?
Yeah.
All right. Yeah, maybe it's because what they're eating. All right.
It's so obvious when you start to unpack all this. This is what I've discovered, which is I learned all the science, right? Pharmacy is very, very scientific. It's nothing like as clinical as medicine, but it's very scientific. So we learn, everything from the Krebs cycle to, electron transport chains. We learn this fundamental science.
Right. And then you stop using it.
And then what I don't understand is how all of these professions, pharmacy, dentistry, optometry, medicine, nursing, we may learn more of the science. Generally, medics learn more of the clinical aspects, but we all have a kind of collective understanding. And yet we end up in this bywater that makes no sense. And when you go back to the science, it's so freaking obvious.
Well, this is what cognitive dissonance is about.
Yeah.
You know one thing and then you hear another thing and it doesn't make any sense. All right. And I think all doctors are in this cognitive dissonance because they're taught this one thing in medical school, which I was taught too, know, and then it doesn't work. And, that's why, we have this, sort of blow up Now you've got cognitive dissonance in social media, but you've not, but we've got cognitive dissonance in the medical profession, in doctors, dietitians, and dentists. And that's one of the reasons I wrote Metabolical, is to basically explain why they've got the cognitive dissonance, and to take them to task about fixing it.
Yep. Well, next time you take your profession to task, please take my profession to task as well, because we've got a role in all of this, and a degree of guilt in all of this as well.
Well, I don't take pharmacists to task, but I take big pharma to task.
Yeah.
So.
Thank you for watching, and before you leave, if you haven't already subscribed, please do so, and that way you won't miss future episodes with Robert and with our other fantastic guests.